Hello students, welcome to the amazing platform of PW English. So my dear students, today we have reached on the lecture 4 of solutions chapter. My dear students, I hope all of you are super excited because I am very excited. In the last class, we actually discussed about what is the difference between, we actually discussed about solubility, we talked about Henry's law, right? And then we talked about what is the major difference between vapor and gas. And later, we also found out, we also learned what actually is vapor pressure. So now, my dear students, in today's class, what are we going to discuss? Let's see what are we going to discuss. We are going to discuss the spelling of vapor is absolutely wrong here. So let me just correct it. We are going to discuss about the vapor pressure, V-A-P-O-U-R. Okay. Then we are going to talk about the Raoult's law, and then we are going to solve a lot of questions. So my dear students, let me tell you, this Raoult's law is very, very important. It is very important, my dear students. So mind it. Most of the questions from this chapter are asked from this particular part. So let's start the session. So in the last class, we discussed about what is vapor pressure. I told you that vapor pressure is the pressure exerted at the equilibrium, that is your saturated state, where the dynamic equilibrium has been achieved, right? Yes. Vapor pressure is the pressure exerted by the vapor at the dynamic equilibrium at a constant temperature, right? Yes. So we can say that vapor pressure is equal to nRT by V, where we know that N by V is always a constant value. You keep the temperature constant and your gas constant value is actually a constant. So your P, vapor pressure, which is known as your vapor pressure, is also a constant value, right? Yes, I hope you're clear with this concept. Perfect. Now let's move forward. Now let's read what all things we have studied in the last class. Vapor pressure is the maximum pressure exerted by a vapor in the equilibrium with the liquid. Clear? Very good. Vapor pressure represents the pressure of the saturated vapor. What is the saturated vapor? Where the rate of condensation actually becomes equal to the rate of evaporation, right? Yes. Vapor pressure depends only on temperature and nature of liquid. I told you it only and only depends on the temperature. It does not depend upon the number of moles and volume, because the ratio of both is always constant. Next, it says that it depends on the nature of the liquid. Obviously, for one particular liquid, the vapor pressure at particular temperature is constant. For the another liquid at that particular temperature, the vapor pressure will be another value, but that will be constant for that particular value, right? Yes, perfect. Next is vapor pressure does not depend on volume of the container or the amount. Here, my dear students, amount of the liquid is N, right? Yes. So we have studied that the more you will increase the volume of the container, the more the number of moles will increase, and as all in all, N by V will always remain constant value. All these things were actually discussed in the last class. If you have forgotten, then go through the last part, I think 10 to 15 minutes part, and you will be thorough with the concept. Okay, now let's move forward, my dear students. Now what are we going to discuss? We are going to study about Raoult's law. What is Raoult's law? I'll just make you understand each and every part very easily, but first you have to write, you'll write here Raoult's law. Now, to study Raoult's law, my dear students, to study Raoult's law, you actually need to understand few conditions. Okay, so in this particular part, we will only cover those two to three conditions will be applicable. Only then you can study Raoult's law. The most important thing that you have to consider is you will always take a binary solution. You will always take a binary solution. Okay. Whenever we will discuss about Raoult's law, we will consider a binary solution, a solution which has two components. Okay, one is the solute and the other is your solvent. Okay, so I can say that one will be your solute and the other will be your solvent. Okay, let's talk about the other part. Second, so now my dear students, next is you needed to understand a few terms. What are those terms? First term is volatile liquid. Volatile liquid. Just a second, my dear students, just a second. You just have to pause for a second and then we'll move forward. Let's call someone for help. Okay, now we are back again. Okay. Okay. Now, we were talking about the volatile liquids, right? Yes. So, volatile, what does volatile mean? Volatile means the liquids which can exert, which can give vapors. Okay, there are a few substances which can form vapors, but there will be some substances which will not form vapor. Okay, yes. So, the volatile substances will be the substances which will have some vapor pressure. Let's denote vapor pressure as P naught. So if you have a volatile substance, then volatile substance will have some vapors, so it will have some vapor pressure. So this P naught is not equal to 0. It will have some value. So what does volatile mean? That the substances which exert vapor pressure, which can form vapors. Okay, those are your volatile substances. Third is your non-volatile substances. Non-volatile substances. Now, what are non-volatile substances? I hope now you can give me an answer. Ma'am, the substances which cannot form vapor actually will be known as non-volatile substances and there will be no vapor pressure for them. This means that I can say that here P naught will be equal to 0. Right? Yes. Let's denote here P naught as the vapor pressure. Vapor pressure. Right? I hope this is clear with you. I hope you don't have any issue here. Perfect. So, binary solutions, you have to understand the term binaries, volatile substance, non-volatile substance. Now, my dear students, if I ask you some question, if I ask you that, let's say I say that A is more volatile than B, then which solvent P naught, that is the vapor pressure of pure solvent, is higher? Okay, PA naught or PB naught. You have to tell out of PA naught and PB naught, you have two volatile substances A and B, and PA is the pure vapor pressure of pure solvent A and PB naught is the vapor pressure of pure solvent B. If A is more volatile than B, then which is, if A is more volatile than B, then which of the vapor pressure is more? Okay, so now how will you answer this question? First, pause the video, try to give the answer yourself, and then you will have to understand what I am explaining. Now, my dear students, imagine I know that A is more volatile than B. Then at particular temperature T, if A is more volatile, then ma'am, this means that A will form more vapors as compared to B. Yes, if A forms more vapors, then the vapor pressure of A will be more as compared to B. This means that PA naught will be more than PB naught. This means that PA naught will be more than PB naught. So, if a component is more volatile than the other, then its vapor pressure at a particular temperature T will be more than the other. These are the few concepts which you need to understand. Only then we can move forward. So, try to go through this concept, write all this, and then we'll move forward. Okay. So now, my dear students, what I want to make you understand is Raoult's law. What does Raoult's law tell you? Raoult's law actually tells you that if you have a solution of two components, I told you will consider two components, binary solution. If you have a solution of two components and you can calculate the vapor pressure of that solution, you can calculate the vapor pressure of that particular solution. Now it can have two cases. One is that both the components, solute as well as solvent, are volatile. If both are volatile, means that both will have some vapor pressures. If one of them is volatile and the other is not, right? Yes, then that would be the second case. first we will discuss about the first case only. That is the most important part, and then we'll move forward to the other part as well. Okay, let's start. Today we are going to only discuss the first case. Okay, so now you have case 1 where solvent and solute both are volatile, right? You have solvent, you have solute, and both are volatile. Let's call from now on, we will call solute as A, and we will call solute as A, and we will call solvent as B. Okay, clear? Now you have a mixture of these two, solute and solvent A and B. Okay, so let's first draw a container. Okay, so you have a container like this. Okay, you just have to understand, it is very easy, my dear students. Imagine you have this mixture of solvent and solute. This is your solution. Okay, so students, here if I say that solvent and solute both are volatile, this means that PA naught will be the vapor pressure of pure solute, vapor pressure of pure solute. Okay, so this will be the vapor pressure of pure solute. Pure solute means that you calculated this PA naught when there was no solvent present, only and only solute's vapor pressure. Okay, at some particular T temperature. Always you calculate vapor pressure at a constant temperature. Then PB naught will be the vapor pressure. Now in the further classes we will be denoting vapor pressure by VP. Okay, vapor pressure of pure solvent. Okay, my dear students, I hope this is clear with you. Now, you have PA naught and PB naught when you calculated their vapor pressures individually, right? Yes. Now, my dear students, if you talk about this solution, then this solution's vapor pressure will be PS, because it is a mixture of two different components, right? Yes. So, we can say that PS is the vapor pressure of solution. Now, my dear students, what you need to understand here is that this PS is actually equal to PA plus PB. It is not equal to PA naught and PB naught. It is equal to PA and PB. What is PA? What is PB? Now you have to understand this. PA is the partial vapor pressure of A, and PB is the partial pressure of B. Okay, now see, my dear students, see, you know that PA naught and PB naught are their individual vapor pressures when they were alone. Okay, now when the two components are mixed in a solution, they are mixed in the solution, right? Let us say this is one component, the other is this. Now they both will form some vapors. A part also and the B part also, they both will form vapors, and you will calculate some PS vapor pressure, which will be the pressure of the solution. Now this PS will be equal to PA plus BB. PA is the partial pressure of A. You have studied in Dalton's law that what is partial pressure? Partial pressure is that you consider that if only that component was present in solution, what would be its pressure? Partial pressure. Okay, if only B would have been present, then partial pressure of B. Okay, so PS will be the partial pressure of A and partial pressure of B, and my dear students, write it as that PA is not equal to PA naught. The partial pressure of A is not equal to the partial pressure of A, then is not equal to the pure A's vapor pressure. Neither is PB equal to PB naught. Okay, when you talk about a mixture, then the partial pressure, or then the pressures of each gas is considered to be their partial pressures. And if you consider only one solvent and its vapor pressure, that is the pure solvent or solute's vapor pressure. This is the most important part which you need to understand, the difference between all the different types of pressures. Pure components vapor pressure, then if you are calculating it in a mixture, then it will be its partial vapor pressure. Okay, yes, and PS is the solution's vapor pressure. So what Dalton told that this partial pressure will be equal to the sorry, this solution's pressure would be equal to the partial pressures sum of all the components present. Here only two components, so we'll only talk about the two components. Okay, yes, perfect. Now my dear students, now what are we going to do? Now we will talk about the Raoult's law of vapor pressure. Now what does Raoult tell you? That now you have a mixture. Okay, now imagine my dear students, you have a mixture of two components. If in the liquid phase, let us say you have A's amount more as compared to B's amount. Okay, you have a solution in which you have A more than B. Okay, so the vapors of A forming would be more. Yes ma'am, the probability of forming A forming vapor would be more as compared to B. Yes ma'am. So the vapors of A will be more as compared to B also. Okay, so in this way we can say that the partial pressure exerted by a component is directly proportional to the mole fraction of that component in that solution. What does Raoult's law say? That let us say we are talking about PA, then PA will be, the partial pressure of gas A will be directly proportional to the mole fraction of gas in the solvent, mole fraction of that solution, mole fraction of that component in the solution. So this means that more the solution will have the component, more will its vapors formed, and more will be the partial pressure of that particular component in the solution. If you have understood this, I can say that the same case for PB, this will be directly proportional to the mole fraction of B, right? Yes. Now just see, I'll just show you this practically as well. See, you have a system here. Let's make it as mole fraction as 0. Yes, you have 0.5 mole fraction, which means that you have equal number of A and B. Let's say purple balls are A and green balls are B. Okay, yes. Since in the liquid phase, their both mole fraction is equal, that is their moles are equal, mole fraction is equal, which means that ma'am, in the vapor phase also, their partial pressures will be nearly equal. Okay. Now, if I increase the mole fraction of one component, okay, I'll try to increase the mole fraction of that one component. Okay. Let's try to increase the mole fraction of one component. Okay. I have increased the mole fraction of blue. Blue part was, I don't remember, blue was I guess A. Okay, you just understand that I have increased the mole fraction of one component which was blue in the liquid phase. Now in the liquid phase I have blue balls or the purple balls more, then in the vapor phase also I can see blue or purple balls more, right, as compared to green one. So this way we can say that the partial pressure exerted by the B would be more, right? Yes. So this is how you denote that the partial pressure of one gas will be directly proportional to its mole fraction in the liquid phase, In the liquid phase, which component has more of the mole fraction, that will its partial pressure would be comparatively more, right? Yes. So this is the reason we say that PA is directly proportional to XA and PB is directly proportional to XB, where XA is the mole fraction of A in liquid phase. It is very important to write in liquid phase. Okay, I'll just tell you why. And XB is the mole fraction of B in liquid phase. I hope this is clear with you. Now, my dear students, let's move forward. PA is directly proportional to XA and PB is directly proportional to XB. Mole fraction is XA and XB. See, if you remove the proportionality, PA will be equal to some K constant into mole fraction of A, You know that you have a solution and you know that its components are only 2. And I told you the number of components you have, the sum of all the mole fractions is always equal to 1. You have 2 components, then you can say that here mole fraction of A plus mole fraction of B is equal to 1. right? Yes. Also I know that PA naught is the pure vapor pressure. It is the pure vapor pressure of A, right? Yes, vapor pressure of pure A. It would be a better word if I write it as vapor pressure of pure A. Okay, yes. Now my dear students, we needed to calculate the value of K. We need to calculate the value of this constant K. Now, imagine you know that XA plus XB is equal to 1. Imagine you don't have any mole fraction of B. You don't have B. You have B equal to 0. If you have mole fraction of B equal to 0, this means that mole fraction of A is equal to 1. And since mole fraction of A is 1, that means that the whole of the solution actually contains only and only A, right? Yes, this means that you're talking about pure A. If you're talking about pure A, then this pressure will become equal to PA naught. This will be equal to this pressure, PA will equal to be K. This will be PA naught into 1. This means that the constant K value has came out to be PA naught, right? Yes. So now if you take it as 1, you can put in 1, you get the expression as PA is equal to PA naught XA. So this is the expression. I'll just make you understand it again. Now see what we did. We just knew that P, according to the Raoult's law, PA is directly proportional to the mole fraction of A in the liquid phase. I removed the proportionality, I added a proportionality constant, but I need to calculate the proportionality constant's value. So what I considered that, let us say that the whole of the solution has only one component, which is A. If whole of the solution has only one component A, that means you don't have B, mole fraction of B is 0. If the mole fraction of B is 0, if the mole fraction of B is 0, my dear students, just a second. Yeah. If the mole fraction of B is 0, my dear students, what will happen? If the mole fraction of B is 0, this means that mole fraction of A is 1 and it is pure A. And if it is pure A, then the pressure would be equal to the PA naught. Yes, ma'am. So this pressure will become equal to PA naught, K into mole fraction of A, which was equal to 1. So we said that K came out to be PA naught. We put this value in this and we get expression that partial pressure of A is equal to pure A's vapor pressure into the mole fraction of A. Similarly, you can calculate for B as well. Let's calculate for B. See, if you have PB, then this will be equal to K into mole fraction of B. PB will be equal to K into mole fraction of B, right? Yes. Now, my dear students, now we will say that PB naught is the vapor pressure of pure B, right? Yes. Now, what will I consider? If the whole solution was only of B component, then what will happen? That means that XB will be equal to 1 and you don't have XA in it, then this will be equal to 0. Now, put this, right? Put this value. What will you get? The whole pressure will be because of PB naught, because it is pure B. This will be equal to constant K into 1. So, from here, K has came out to be PB naught. Let us say this is 2. So, you have to put in 2. You can say that PB is equal to PB naught XB. This is the expression for partial vapor pressure of B. Okay, yes. From Raoult's law, we know that PS is equal to PA plus PB, right? Yes. From the initial start, we know that the partial pressure of the solution is always equal to the partial pressure of first component plus partial pressure of the second component. Okay. Yes. And I also know that I just calculated that PA is equal to PA naught XA. Also, I calculated that PB is equal to PB naught XB. Yes, just put this in this part. I can say that PS is equal to PA naught XA plus PB naught XB. Yes or no? This is the final expression. If you have a solution of two volatile components, then you can calculate the partial pressure of that component by this formula, that is the total pressure of the solution will be equal to the partial pressure of A component plus partial pressure of B component, which is equal to PA naught into mole fraction of A in the liquid phase plus PB naught into mole fraction of B in the liquid phase. Only this is what you need to remember. This is Raoult's law. Simply, very easy part, my dear students. You know how to calculate mole fractions and you can calculate any question. Now let's solve a question and then we'll understand. Okay, first we'll revise the part. See, we started from this part that when your solution has two components and both of them are volatile, means both will have vapor pressures. Okay, PA naught and PB naught are the pure components vapor pressure. PA and PB are the partial pressures when they are in the solution phase, and PS is the vapor pressure of the solution. I know that solution's vapor pressure is PA and plus PB. So I need to calculate what is PA and what is PB. So what does Raoult's law tell you? Raoult's law tells you that the partial pressure of a component in a mixture is directly proportional. You'll get the definition as well, don't worry. First understand it. The partial pressure of a component in a solution is directly proportional to the mole fraction of that component in the liquid phase. The partial pressure of one component in a solution is directly proportional to the mole fraction of that component that component in the liquid phase. We use this concept. We found out a proportionality constant. Now, I know that PA naught is the vapor pressure of pure A. Okay, if I consider that this solution has only one component, then the vapor pressure will only be because of A. Then I can say that if XA is equal to 1 and XB is equal to 1, then PA, I can write that. Just I'll write here, you will understand it, that PA will be equal to PA naught, right? If whole of the component is A, then the pressure would be only because of A, which will be equal to PA naught. So PA naught is equal to K into 1, which is equal to PA naught. Now you have to put it in this expression and you will get the expression of partial pressure of A. Similarly, you will calculate for B and then you will put it in the solution formula. And this is your only formula which you need to know. You don't need to memorize n number of formulas which you see in your books. You only need to know this formula and you can solve any question. Let's solve a question and we'll understand this very easily. First, you need to know the definition as well for Raoult's law. So see, partial pressure of any component is directly proportional to the mole fraction of that component in the liquid solution. Means if you are calculating for PA, then this will be directly proportional to XA and then PA will be equal to PA naught XA. The whole definition we've done earlier. Okay, perfect. Now let's solve a question and understand the concept. Here is the question. Try the question yourself and then you will see how I have solved the question. Okay. The question says that at 25 degrees Celsius, the vapor pressure of pure liquid A, whose molecular weight is 40, is 100 torr. So my dear students, you are given PA naught equal to 100. Okay. Whatever the information is given, just write it. While that of pure liquid B is 40 torr. Okay. The vapor pressure of a solution containing 20 grams of each A and B. So you are given molecular weights as well for A. What is the molecular weight of A? It is 40. And what is the molecular weight of B? It is given to be 80. Okay. And also you are given weights of A 20 grams and weight of B equal to 20 grams. It said that you have 20 grams each of A and B. Okay. Yeah. So can you calculate the moles of A from here? Yes, ma'am. Moles of A will be equal to given mass of A upon molar mass of A, which will be equal to 20 upon 40, which is equal to 1 upon 2. Similarly, you can calculate the moles of B, which will be equal to given mass of B upon molar mass of B, which will be equal to 20 upon 80, which is equal to 1 upon 4, right? Yes, perfect. This is how you calculate moles of A and moles of B. Now, can you calculate their mole fractions as well? Yes, ma'am, it is very easy. It is a binary solution. It has two components. So I can say that mole fraction of A will be equal to moles of A upon moles of A plus moles of B. Moles of A are 1 upon 2 and moles of B are 1 upon 2 plus 1 upon 4, right? Yes, it is very easy. Perfect. No issues, my dear students. Let's calculate it. This will be 1 upon 2 upon, you will take 4 LCM. Then this will be 2 plus 1. This will be 1, 2. This will be, I think, 2 by 3. Have we calculated it correct? This will be 2 and that would be 1. Yes. So 2 by 3 is the mole fraction. Okay. So mole fraction of B will be equal to, since it has two components, so I know that mole fraction of A plus mole fraction of B should be equal to 1. So 1 minus mole fraction of A will be equal to mole fraction of B, right? Yes. So 1 minus 2 by 3 will be equal to 1 by 3 and that would be the mole fraction for B. I have calculated both mole fractions, right? Yes. I have to calculate the vapor pressure of the solution. So for the vapor pressure of the solution, I know that this will be equal to PA plus PB. This will be equal to PA naught XA plus PB naught XB. I have calculated both the mole fractions, right? See, PA naught is 100 into mole fraction is 2 by 3. So 100 into 2 by 3. This will be 100 into 2 by 3 plus PB is equal to, what is PB? 40 into mole fraction of B is 1 by 3, I guess, right? 1 by 3, yeah. This is 1 by 3. Okay, yes. Let's solve this. This will be equal to 200 by 3 plus 40 by 3, which is 240 by 3, right? Yes. This would be 80, right? Yes. So the solution vapor pressure would be 80 torr. 80 torr. So option A is your correct answer. So option A is your correct answer. This is how you will solve such type of questions. Okay, let's move forward. I hope you're clear with this concept. I just wrote what I was given. I calculated the moles, I calculated the mole fractions, and I just put the values in the formula and I got my answer. So easy. Let's move forward, my dear students. You have another question here. The question says that two liquids A and B form an ideal solution at 300 Kelvin. The vapor pressure of A solution containing 1 mole of A and 3 moles of B is 550. Okay, this is a typical question. We'll solve this question, but not right now. Okay, we'll solve this question, but not right now. Try to do this question. Okay. What does this question say? A mixture of ethyl alcohol and propyl alcohol has a vapor pressure of 290 mm at 300 Kelvin. So my dear students, it is given the vapor pressure of the mixture. This means that you are given PS. You are given PS of solution equal to 290 mm. Okay. Perfect. No issues. Okay. The vapor pressure of the propyl alcohol is 200. So you are also given the P naught value of propyl alcohol, let us say PA, which is equal to 200. Okay. If the mole fraction of ethyl alcohol is 0.6, if you are given the mole fraction of, you don't know ethyl alcohol's PA naught, but you are given mole fractions of ethyl alcohol equal to 0.6. You are given 0.6 value. Okay. Its vapor pressure at the same temperature is, so you have to calculate PE, that is the pure ethyl alcohol's vapor pressure. How will you calculate? Now, my dear students, you know that it is a binary solution. So I know that for a binary solution, the mole fraction of ethyl alcohol plus mole fraction of propyl alcohol should be equal to 1. So if it is 0.6, then the mole fraction of propyl alcohol will be equal to 0.4. 1 minus 0.6, which will be 0.4. So now you have mole fractions of both, right? I know that P of solution is equal to PA, P of propyl alcohol plus P of ethyl alcohol. This is P naught of propyl alcohol into mole fraction of propyl alcohol plus P naught of ethyl alcohol into mole fraction of ethyl alcohol, right? Yes. What is the value of PS? PS is given to be 290. Okay. Are you given PA naught value? Yes, it is 200. Do you know mole fraction of PA naught? Mole fraction of propyl alcohol? Mole fraction of propyl alcohol is given as to be 0.4. So this will be 0.4. I hope this is clear. Plus, my dear students, PE naught, you don't know, you need to calculate. Now this mole fraction. Do you know the mole fraction? It was given to be 0.6. So this is 0.6. You just have to solve this and you will get the value for PE, P naught EA, right? Yes. So just calculated it and correct and take the correct answer. Such easy questions, my dear students. Those are very easy questions. You just need to understand how you have to apply these concepts. Okay. Yes. Now I'm going to tell you a very important thing. See, my dear students. I told you very clearly, I told you that PS is equal to PA plus PB. I told you this? Yes, ma'am. Also, I told you that PS is equal to PA naught XA plus PB naught XB. Right? Yes. From here, we know that PA is equal to PA naught XA and I know that PB is equal to PB naught XB. So now what I am going to do is I am going to derive a lot of expressions which you see in a lot of books and you try to memorize it. I just want to show you that without knowing these expressions, you've solved the questions. Without knowing these expressions, you've solved the questions. So you need not remember them, but you need to derive them. Okay? Yes. See. You know this? You know this. Okay. Do you know that mole fraction of A is actually equal to moles of A upon moles of A plus moles of B? And mole fraction of B is equals to moles of B upon moles of A plus moles of B? Yes, ma'am. We know this. Yes, perfect. So put this into this expression. So PS will be equal to PA naught moles of A upon moles of A plus moles of B plus PB naught into moles of B upon moles of A plus moles of B. This means that PS is actually equal to PA naught plus PA naught into moles of A plus PB naught into moles of B upon moles of A plus moles of B. Okay. So this expression you see in a lot of books, but you don't need to memorize it. You don't need to memorize it, my dear students. If you know the concept, you can solve any question without this expression as well. Okay. So this expression is seen at a lot of times. Okay. You've done this. Now let's derive another expression. You know that PA is equal to PA naught is equal to PA naught XA and PB is equal to PB naught XB. See, I can write it as PA naught moles of A upon moles of A plus moles of B. I can write this as PB naught moles of B upon moles of A plus moles of B. We can write them like this. Yes. This is your first equation. This is your second equation. What you are supposed to do, let me just draw a line and separate these two. Okay. Now, you know this. What are you going to do? Divide 1 by 2. Divide 1 by 2. If I divide 1 by 2, what can I say? I can say that PA by PB is equal to PA naught mole fraction of A upon PB naught mole fraction of B. Right? Divide those as well. This will be equal to PA naught NA by NA plus NB upon PB naught into NB upon NA plus NB. Right? Equal. So you can cancel them. So what are you left with? PA by PB is actually equal to PA naught XA upon PB naught XB, which is equal to PA naught NA upon PB naught NB. This is the expression. You come across. Right? Easy. But do you need to remember this? If you know that this is equal to this, you can calculate anything. You don't need to memorize it, right? Yes. But these expressions are present in various books. So I need to tell you the expressions, how to derive them. Okay. But you need not memorize them. Don't memorize them, right? I hope this is clear. And my dear students, one important thing from here which you can derive is that always and always a solution's vapor pressure will be between the vapor pressures of pure A and pure B. This means that if you have PA naught, let PA naught is more than PB naught. So you have a solution of two components in which the vapor pressure of pure A is more than let us say you have a solution of two components in which the vapor pressure of pure A is more than the vapor pressure of pure B. Then, my dear students, always and always your solution's pressure will be in between the two. It will always and always be between the two values. It can never be more than both or less than both. It will always be in between, which is told by this particular expression, because you see that it is the average, it is the molar average here, and that is the reason that the solution's vapor pressure will always be in between the pure solvent's vapor pressures. It cannot exceed or it cannot be less than the vapor pressures of pure A and B. Okay, so these are the expressions which you need to understand. You can write these, pause the video, and you have to try doing these yourself. You have to try doing these by yourself. Okay, yes. Try to please write it down and then we'll move forward. Don't memorize these expressions. You know you can solve the questions without these expressions as well. Okay, let's move forward. I hope you've written it. Let's move forward. So here is the question which I told you that you will not be able to do, but now you can do. I'll give you the hint and you will have to solve the question because there is a lot of calculation. So we'll not solve completely, but I'll give you the steps. You have two liquids A and B which form an ideal solution. Okay, so you have two components. The vapor pressure of a solution containing 1 mole of A. So you are given moles of A equal to 1 and moles of B equal to 3. So you can calculate mole fraction of A as 1/4 and mole fraction of B as 3/4. Right? Yes. And what are you given? That the vapor pressure of a solution. The solution's vapor pressure is given as 550. So PS is equal to 550. Let us say the pure vapor pressure PA naught is this and the pure vapor pressure of B is PB naught. Right? Yes. So from this I can say that PS is equal to PA naught XA plus PB naught XB. So what can we say? That 550 is equal to PA naught into XA is 1/4 plus PB naught and XB is 3/4. So this is your first equation. This is your first equation. Okay. We have done everything till here. Let's see what the other part says. Let's see what the other part says. The other part says that at the same temperature, if 1 mole of B is added to the solution, means that now, my dear students, Na dash moles of Na is equal to Na, which is equal to again 1 because A's mole were not affected, but they added 1 more mole of B. They added to the solution 1 mole of B more. So this time moles of B are, which were initially 3, now you added 1 more, now the moles are 4. So the mole fraction of A will be 1/5 and mole fraction of B will be 4/5. Right? Yes. Further it says that the vapor pressure of the solution increases by 10. Whatever the initial vapor pressure was, it increased by 10. This means that the solution's vapor pressure, initially it was 550, it increased by 10. That means that it has now become 550 plus 10. which is equal to 560, right? Yes. So your expression according to the Raoult's law, PS dash will be equal to PA naught XA plus PB naught XB. Right? Now put the values from this expression into this. What will it be? You will say that 560 is equal to PA naught into 1 upon 5 this time into PB naught into 4 upon 5 this time. So this is your second equation and this is your first equation. You have to just solve the two equations. You have two variables, you have two equations. Solve the two equations, you will get the value of PA naught and PB naught, and you have to calculate the vapor pressures of pure A and B only. See, it was a very tricky question, but when you did this question step by step, it was not difficult at all. Whatever I told you, just do the steps accordingly. You will solve the question in minutes, okay? So I hope you're clear with this concept. Just try to understand this and then we'll move forward. I'll have some water and then we'll move forward. See. You're given, initially you were given moles, you calculated mole fraction. Then you were given solutions pressure, you wrote it into the expression and you made one equation. Then it gave you a condition that to the existing solution you added 1 mole of B. So you calculated the mole fractions again. Solution's vapor pressure increased by 10. So you calculated the new pressure of the solution. You wrote it into the expression and you just calculated. Okay. So you got two equations, two variables, solve them and you will get your answer. Super easy. Perfect. No issues till now. Let's move forward, my dear students. Okay, now after this, now I am going to let you understand a very important part, which is Dalton's law. Yes, my dear students, in class 11th you studied Dalton's law. So the topic is relation between relation between Raoult's law and Dalton's law. So now we are going to find out the relation between Raoult's law and Dalton's law. Okay. So for this, first we need to remember the Dalton's law, which I am 100% sure you 100% would have forgotten, right? Yes. So first understand what was Dalton's law. What Dalton's law said that, my dear students, it said that you have a container. Let's say you have a container and you have in this container two gases. Dalton's law was only and only applicable to gases. Okay, it was only and only applicable to gases. Now imagine you have two gases. Okay, so let's say YA is the mole fraction of component in vapor phase. Let me say it was applicable to vapors. Okay, gases is okay. Vapor is a special form of it. YB is the mole fraction of component B and A in vapor phase. Okay, Now, you have two different gases. You have two different gases here, my dear students. A mixture of two different gases. So, if you calculate the total pressure here, let's call it PS. If you calculate the total pressure here, my dear students, it will be equal to PA plus PB. You have two components, the same components which we studied in the liquid phase A and B. This time we are discussing them in the vapor phase only, and PA and PB on both those components. So here PS is the vapor pressure of mixture, okay, and PA again is the partial vapor pressure of A, and PB is the partial vapor pressure of B. Okay, you have understood this part. So YA and YB this time are the mole fractions in the vapor phase. XA and XB were the mole fractions in the liquid phase. PA and PB still are the vapor pressure of partial vapor pressures in the gaseous mixture, and PS is still the vapor pressure of the solution. Now, my dear students, according to the Dalton's law here, according to Dalton's law, what you used to say that partial pressure of A is equal to P total into mole fraction of A in the gaseous phase. This was what is known as Dalton's law, and PB will be equal to the total this PS or PA, PS into mole fraction of B. This was what is known as the Dalton's law. I hope you can memorize it or you can understand it. I am not going to discuss the complete Dalton's law, my dear student, here, but I will tell you what each and every term denotes. Here, each and every term denotes that PA is the partial pressure of A, PB partial pressure of B, PS is the total pressure of the mixture, YA and YB this time are the mole fractions in the vapor phase, XA and XB were the mole fractions in the liquid phase. This is the major difference. Okay, yes. You can write this, then we'll move forward. Okay. I hope you've written it. You've paused the video, you've written it. Now we are going to find the relation between Dalton's law and Raoult's law. Okay. See what will happen. Imagine you have a container. Imagine you have a container here and you have a mixture of, you have a liquid mixture. Okay. You have a liquid mixture of A and B components. Okay. Now, my dear students, this is the liquid form, or I can say this is the solution, and here you have the vapors. So this is the vapor form. Okay. Now, one by one, we are going to understand each and every part. First and the most important thing is, in the liquid, you will have component A and B. So the mole fractions in the liquid will be XA and XB. So from this, I can say that XA, comma XB are the mole fractions in liquid phase. In liquid phase. Okay. Now, this is the vapor. Now, these component A and B which were in the liquid phase, they might have formed some vapors. Yes, ma'am. Now, in vapor also, they will have some fraction. In the vapor, they have, let us say, YA and YB fractions. Okay. So, from here, we can say that YA and YB are the mole fraction in vapor phase. Right? Yes. And we know that the total, I can write it here, that PS is actually the total vapor pressure of solution, of mixture or solution, right? Total vapor pressure of the solution, right? I'll write solution only, then you'll understand. So it is the total vapor pressure of the solution. Clear? Yes. What is PA, my dear students? What are PA and PB? These are the partial vapor pressures. These are the partial vapor pressures. Okay. Yes. So partial vapor pressures will be in the gaseous mixture here. And PA naught and PB naught are the vapor pressures of pure solvent, of pure component. Yes, I hope all the terms are clear. If all the terms are clear, you are crystal clear with this concept also. Okay, I hope you're clear now. Now, I know that according to Raoult's law, according to the Raoult's law, according to the Raoult's law, I know that very simply that PA is equal to PA naught XA and PB is equal to PB naught XB. Clear? Yes. And according to Dalton's law, we just calculated that the same PA is equal to P total into Y of A. This time you are using the mole fraction in the vapor phase, and PB is equal to the P total into mole fraction, not total, write it as PS and PS mole fraction of B. Okay. Also, my dear students, we all know that PS is always equal to PA plus PB. It is always equal to PA plus PB. This PA and this PA are equal. This PB and this PB are same, right? Yes. So this is 1, this is 2, this is 3, and this is 4. From 1 and 3, we can say that this PA is actually equal to PA naught XA, which I calculated from Raoult's. This I calculated from Raoult's, right? Yes. And same PA is actually equal to PS into Y of A. This I calculated from Dalton. So, my dear students, only and only this expression you need to understand. Only and only this is the relation between Raoult's law and Dalton's law. Okay. So, if I know this, that PS is equal to YA, this expression is equal. So, what can we say? We can say that PS into Y of A is equal to P A naught into X A. Right? Yes. If I have used this part, I have to use B1 part as well. I can write here that PB will be equal to PB naught XB. This will be equal to PS into Y of B. Right? Yes. So I have to use this expression as well. I'll have to equate this. Let's equate this as well. PS into Y of B will be equal to PB naught into X of B. Right? Yes. Let us say this is 5 and this is your 6th expression. Okay. So now what you have to do, just divide 5 by 6. Divide 5 by 6. What will you get? PS into Y of A is equal to PA naught XA upon PS into Y of B is equal to PB naught XB. Okay. So PS can be cancelled out by PS. So from here, you can say that Y of A upon Y of B is actually equal to PA naught upon PB naught into X of A upon X of B. Also, my dear students, you actually calculated this. This will be equal to PA naught moles of A upon PB naught moles of B. So this is the expression which you need to use in the numericals. So easy. So easy. If you know Raoult's law, if you know Dalton's law, you can calculate anything and everything. Okay. I'll make you and revise all the things again. So from here we started. Okay. Dalton's law is only applicable to the vapor phase. Okay. You are calculating here that mole fractions of YA and YB are in the vapor phase. This is the new thing which you need to know. And according to Dalton's law, partial pressure of A is always equal to the total pressure into mole fraction in the vapor phase. Partial pressure of B will be equal to total pressure of the solution into mole fraction in the vapor phase. Okay, using this expression, I have written everything according to Raoult's law. What is partial pressure equal to? What PA naught PB naught denotes? What XA XB denotes? Then according to Dalton's law, this is the expression. You need to equate them. You did equate them, and when you equated them, you got the expression this. You got the expression this, and you use this expression for the formulas. You use this expression for the formulas. Easy? Easy? Yes. I know it is a little tricky for the first time when you understand this, but once you will write each and every derivation yourself, you will be crystal clear with the concept. Let me tell you, you will be crystal clear with the concept. Okay? Yeah. So just do this, my dear students. You will be very clear with the concept. Perfect? Yes. Write the Dalton's law expression. I'll make you revise it. Okay? I'll make you revise it. Let's revise everything. Let's revise everything. What all things you need to remember. Okay, all those expressions are okay if you want to understand it, but what all you need to remember are these things. For Raoult's law, you just need to know that PA is equal to PA naught XA, and you need to remember PB is equal to PB naught XB. Okay, and you need to know that PS is equal to PA plus PB. So PS is equal to PA naught XA plus PB naught XB. If you know this, you can solve all the questions related to this. I think everything is clear till now. Now, next part is your Dalton's law. Let's talk about Dalton's law. From Dalton's law, you just need to know that PS is equal to PA plus PB. Okay, and PA is equal to PS into Y of A, and PB is equal to PS into Y of B. Now you just need to equate these two. Okay, so equate these two. You will say PA naught XA is equal to PS Y of A. PB naught XB is equal to PS into Y of B. Only this expression. Divide these two, do n number of calculations, it doesn't matter. You just need to understand only this part. Okay, I hope it's clear with you, my dear students. Yes, so this is how you are going to solve all the numericals related to Raoult's law, and I'm telling you a lot of questions are asked from the Raoult's law and the Dalton's law as well, mixture of both. So now we are going to practice few questions. Let's solve some questions, my dear students. Here is the question on the screen. Try to solve the question yourself. Okay, read the question and then we'll move forward. What does the question say? You have two liquids A and B have vapor pressures in the ratio PA naught PB naught. So you are given ratio PA naught to PB naught equal to 2/3. Okay. At a certain temperature, assume A and B form an ideal solution and the ratio of mole fractions of A and B in the vapor phase. Very important, my dear students. You are given the ratio of the mole fractions in the vapor phase, which means that you are given YA upon YB value equal to 1/3. Then you have to give the mole fraction ratio of A in the solution at the temperature. Okay, so I know from this expression, we just calculated the expression this. YA upon YB is equal to PA naught XB, PB naught. We'll use this expression. So I know that YA upon YB is equal to PA naught XA upon PB naught XB. I know that XA plus XB will be equal to 1 because there are only two components. So we can write as PA naught XA upon PB naught 1 minus XA. We can write it like this. Yes, you are given this ratio equal to 1/3. You are given this ratio as 2/3 into you have XA and you have 1 minus XA. So my dear students, see, you have just one equation to solve and you have only one expression. XA. You can calculate the value of XA from here and just take the answer. This is how you are going to solve these types of questions. Very easy questions if you're thorough with the concept. So you need to be thorough with the concept. Okay, I hope you're clear with this. Now let's move forward. So now you have a next question. The vapor pressure of benzene and toluene are this and this respectively. If the mole fraction of benzene in the solution is 0.6, calculate the mole fraction of benzene in the vapor phase. I hope you can do this question. Can I give you this question as your homework? I hope you can do this question. So this will be your homework question, my dear students. Just use the expression which I told you, the relation between the vapor phase and the mole fractions in the vapor phase and the liquid phase. Okay. Yes, I hope you're clear. Let's move forward. Next question is here. Okay, so again you have to try this question. Let's try this question. What does this question say? The vapor pressure of A and B at 25 degrees Celsius are 90 mm of Hg and 15 mm of Hg respectively. So the vapor pressure of A and B are, so you have been given PA naught equal to 90 and you are given PB naught equal to 15. Okay, yes, respectively. If A and B are mixed such that the mole fraction of A in the mixture is 0.6. So you are given mole fraction of A equal to 0.6. The mole fraction of A in the mixture is 0.6. Then the mole fraction of B in the vapor phase is. You have to tell the mole fraction of B in the vapor phase. Is the question. Now we have to do this question. Okay, so you are given PA naught and PB naught and you are given mole fraction in the liquid phase. So can you say that mole fraction of A plus mole fraction of B will be equal to 1? So mole fraction of B will be equal to 1 minus mole fraction of A. So 1 minus 0.6, which is equal to 0.4. I hope this is clear. Yes ma'am, very clear. Okay my dear students, so you are thorough with this concept. We know that PS is equal to PA naught XA plus PB naught XB. So you will have to put these values, 90 into 0.6 plus 15 into 0.4. So this will be equal to, let's try to calculate it. What will be this equal to? 90 into 0.6. This will be 54. So here it will come out to be 54. Then you have 15 into 0.4, which is equal to 6. Okay, so this is equal to 6. So this is equal to 60. So the the pressure of the solution, vapor pressure of the solution has came out to be 60. You are supposed to calculate Y of B. You are supposed to calculate Y of B. My dear students, from Dalton's law, we know that from Dalton's law, we know that PB will be equal to PS into mole fraction of B in the vapor phase, right? Yes, this is clear. Yes. Now, what is PB? PB is equal to this part. I hope you know that. You know that PB is equal to PB naught XB, which came out to be how much? 6. Yes. So 15 into 0.4, which is 6. So PB is equal to 6. Okay. So I can say that, I can put it into this. 6 will be equal to PS. We just calculated PS, which was equal to 60. So ma'am, this will be equal to 60, right? 6 is equal to 60 into mole fraction of B in the vapor phase. So the mole fraction of B in the vapor phase will be equal to 6 upon 60, which is equal to 1 upon 10. Okay, so this is equal to 0.1. What are you given? You have to calculate the mole fraction of B in the vapor phase in the form of x into 10 raised to the power minus 1, which means that this can be written as 1 into 10 raised to the power minus 1. So your x value is equal to 1. So your x value is equal to 1. So this is how you are going to solve this question, right? Yes, very easy question. You just need to use all the expressions that you have calculated. So now let's see how we solve this question. The vapor pressure of A and B, you were given the pure vapor pressures of A and B. I wrote them down. Then you were given that A and B are mixed such that the mole fraction of A in the mixture is 0.6. So in the liquid phase, you were given the mole fraction as 0.6. If you know XA, then you can calculate XB, liquid phase mole fraction 0.4. 1 minus 0.6 will be equal to 0.4. Okay. Okay. you have to calculate the mole fraction of B in the vapor phase in the form of x into 10 raised to the power minus 1. Okay, so now I know that the solution's vapor pressure is equal to PA naught XA plus PB naught XP, right? So I calculated the solution's vapor pressure I equal to 60. Perfect. Okay, now for calculating the mole fraction in the vapor phase, I need to use the Dalton's law, and according to Dalton's law, I know that PB is equal to solution's vapor pressure into mole fraction in the vapor phase. So I have calculated this. I have to calculate this. How will I calculate PB? From Dalton's law, I know that PB is equal to PB naught XB. And I have calculated PB naught XB. 15 into 0.4 is equal to 6. So PB value is 6. PS value is 60. I have calculated Y of B. So Y of B came out to be 0.1, which is equal to 1 into 10 raised to the power minus 1. So X value is 1. This is how you are going to solve this question, right? Yes, perfect, my dear students. Very good. And with this, we have came to the end of our session. I hope you are very clear with the concept, my dear students. Raoult's law is a very important part of this particular chapter. You need to be crystal clear with this concept. If anything is still in a doubt, just rewind it and go through the part again. So I wish you will study very hard. You will try all the questions yourself. If you are not able to solve any question, then see my how I have solved the question. See that and try that question yourself. That is the most important part. Okay, and try to do the PYQs. That will let you gain a lot of confidence. Okay, yes, so I hope you're very clear. We'll check out that NEET question because I think one value is missing there. We'll just see. Okay, my dear students, let's meet in the next session. Till then, keep studying. All the very best.